Good morning, everyone. Today we're going to just watch a quick video on another problem based off the mean value theorem, and then we're going to have you guys do a little delta math for the in-class / homework tonight. As always, you should pause the video whenever needed, try to work through the problem together, and then press play to reveal the answer. Today we're looking at the mean value theorem again. Mean value theorem, remember, it's the hypothesis that has to be met first, so the function has to be continuous on a closed interval, differentiable on the open interval. And if those two conditions are true, then there exists at least one point, a c value, with the instantaneous rate equal to the average rate of change. Or another way to state that is the derivative of the function is equal to the average rate of change, or the slope. Here's our quick little image. We have our secant line, and this function is closed and continuous, so therefore we have at least one. In this case, we have three different locations where the tangent line is the same as the secant line. All right, let's try this problem here really quick. This one is definitely more challenging than what we saw yesterday. The function is f of x. It's x times cosine of 2x, so right away, if you're thinking derivative, hopefully you're seeing a product rule and you're seeing a chain rule. It's on the interval. Notice it's the closed interval from pi over 2 to pi. Find the value c that satisfies the mean value theorem. And then we'll look at this both algebraically and graphically. So just quick, what do we have to do? We have to first determine if f of x is continuous and differentiable. Well, x is a continuous function. Cosine is a continuous function. So therefore their product is a continuous function. And the same goes with differentiability. So the first two conditions are met. I'm going to write that down. So now that we know it's continuous, differentiable, we now have to find the average rate of change. In order to do that, we need the y values for each input. So I'm going to go ahead and find f of pi over 2. Hopefully you're going to do this without a calculator. And I'll do the same thing and find the output at f of pi. Alright, so when I plug pi over 2 in, I get pi over 2 times cosine of 2 times pi over 2. Well, 2's cancel out. That's really just cosine of pi. Think of your unit circle. Cosine is the x value. So my value here is cosine of pi is -1. And -1 times pi over 2 is -pi over 2. So there's my x value, here's my y. Do the same thing at pi, plug in pi. Then I got to evaluate cosine of 2 pi. Well, 2 pi is the same as 0. So the cosine at 0 degrees or 0 radians is 1. And 1 times pi is pi. So now we can find the average rate of change. I'll let you do that. So difference of your x's, so I just decided to do pi over 2 minus pi on the bottom, and then difference of your outputs, -pi over 2 minus pi. Well, what I need to do now is just simplify the numerator and denominator. Think of these as fractions. Each one of these needs to have a 2 in order to combine them. So think of this as -pi over 2 minus 2 pi over 2, while -pi minus 2 pi is going to give me -3 pi over 2 for the top. And then the bottom we get pi over 2 minus 2 pi over 2, which will give me -pi over 2. And then we're stuck with that whole idea of a fraction divided by a fraction. So we don't love that. We're going to take and multiply by the reciprocal instead. So let's times by the reciprocal here of 2 over -pi. And you'll see that something very nicely happens. The 2's reduce out, the pi's reduce out, and a negative divided by a negative turn into a positive, and all that's left over is 3. So my average rate of change is equal to 3. The next thing we have to do is take the derivative and set it equal to the average rate of change. So there's the next step. Go ahead and find the derivative of f of x. Remember, you're using the product rule and the chain rule. So when I take the derivative of the original function, we've got the product rule. The derivative of the first times the original second, plus the first times the derivative of the second. But notice we have a chain rule, so that's where that extra 2 comes in. And then I just combine 2 times negative 1 times x to get negative 2x, sine of 2x. So now comes the fun part. We need to take our average rate of change and set it equal to the instantaneous rate of change. Now at this point, we're going to graph this. So go ahead and grab your calculator. Mostly because this doesn't really factor out well. It's not going to help us out a ton trying to do it algebraically. So grab your calculator. We want to type in one of the equations as the average rate of change, and the other one is the instantaneous rate of change equation. And then I'll show you a little trick here. And you can hit pause at any time you need. Our interval is from from pi over 2 to pi. Well, let's set that as my window. So go to Window, and let's go second pi over 2. And as soon as I hit enter, it converts it to a decimal. And then we're going to go to pi. And then I decided to have a y min of -5, a y max of 8. And if we graph those, here is the graph of the derivative. Here is the graph of the average rate of change of 3. And our job is to figure out where those two values equal to each other. So we're going to go to second calc, find the intersection point. And then we got to scroll over roughly to the first intersection point. First curve, hit enter. Second curve, we're already on the red one, hit enter, take a guess. There's my first answer. I'll scoot that over here and come back. Then I have to find the other answer. So we're going to do the same thing. Go to intersect. Excuse me. And get to as close as we can. Take a guess. Hit enter, enter, enter. And there's the second value. So what did we just find? We found that C is equal to, we'll start with the smallest one first, 2.078 if we round to 3 decimals, and 2.964. So now let's justify that graphically, and I'll show you what we can do here. So I'm going to use Desmos here, and what I actually did was I graphed the entire function of f of x. It's a pretty crazy graph. And then I graphed it over the domain from pi over 2 to pi. And if I turn off the original graph, you can see this is the value that we're looking at. So nothing super crazy. I'm going to actually kind of re-image this and pull it over to the screen, to our slide. All right, so finally, here's the graph of the original function from pi over 2 to pi. And what I did then was I took and I drew in the secant line between the two endpoints. And then I took this parallel line and I'm going to move it over here, and notice I kind of already mapped out our first answer, 2.078. And then the second answer, notice we're parallel to the secant line at 2.964. And again, these are estimates, but you can see that those two values that we found for C give us the tangent lines that have the same slope as the secant line, and that's what the mean value theorem does. All right, so what we got is your homework tonight is 5.2 day 2 on Delta Math. I want to show you one quick thing about that assignment. So you've got 5 different categories that you're going to work through and a couple problems from each. The first one is very similar to what we did on Monday. The only difference here is what they want you to do first is you're going to go from, you have the function f of x, and then you want to plot a line segment that connects the x values of the domain. So we're going to go from -7 to -4. So what we want to do is we want to click on that, and then click it once, and then click again, and you'll go to -4. Now there's your slope of your secant line, and you want to find the x value that gives you the line tangent to that with the same slope between that interval. So you know it's probably going to be somewhere right here. Your answer is going to be somewhat close to in between -5 and -6. Right? So that's the first part, just show you how to click through that. And the second category is the one that says first derivatives from a graph. So here we're going back to what we did previously in trimester 1. But they want us to make some conclusions about the graph, or about f prime in this case. So it says, given the graph of the function f below, determine all the values on the open interval from -9 to 9 where f prime changes signs. So what you can do here is you can kind of drag your tangent line. So notice here, my derivative is positive. And then I have a derivative of 0, and they actually tell you that derivative up here. And then I go to a negative derivative. So I change signs from positive to negative. So that will occur once. And what we're trying to do is determine all the values of x on the open interval. So I know that at -5, I change signs. And then if I would like, I'm going to hit the plus sign to find the other values, and notice negative slopes, negative slopes. Here's another 0 slope, and then I go to positive slope. So you're going to have to scroll over until you get that, and right there at 0 is another value. And then the last one is going to be right up here at 5. So just wanted to show you that quick to show you how to navigate through, because sometimes that's the hard part about working through Delta Math, is figuring out what they want. All right, so the rest of your time is to finish this assignment. This is officially due tomorrow. It'll be checked. But work through it, and remember there are always those little help values, help videos if you need it. Have a great day. Adios. We'll see you on Wednesday.